Okay, everybody, this is weekend number 2. We made it an entire weekend. Anyway, so this weekend is all about SQL. I shouldn't say weekend, it's just one day. Today, you'll have everything you ever wanted to know about SQL. That's why I call it SQL Bootcamp, as I wrote on the board over there. And it is lecture number 5. If you are in the Canvas system and you're looking at the schedule, we see that this is week number 3 in our week section. And week number 3 covers our relational algebra, and we'll look at that a little bit, but it's mostly SQL, which is chapter 5 or lecture 5 of the PowerPoints. And you'll also notice that the only one assignment, which is program number 3, which is due. And then I have some exercises we'll do in the afternoon after lunch that will kind of help you reinforce the concepts, because it's really hard to learn SQL. It's not really a programming language, but it's a scripting language. But it's hard to, without practice, it's really hard to absorb what the commands are. So we'll spend some time doing that as well. But for the morning up until lunch, it's going to be mostly PowerPoint stuff, because I need to show you some basics. But I think you might enjoy it. It's on bars and beers and drinkers, so it's definitely an entertaining topic. But it's kind of dry, I mean, to put it honestly. You're memorizing, or not memorizing, but looking at syntax, essentially, and how to do something. So that's the game plan. If you have not done so already in the assignments, assignment number 1 and assignment number 2 were due. I believe they are probably due tonight or tomorrow, according to the system. You do want to submit them. I have several submissions already, but those are due at 11:59 p.m. on July 25th, which is today. So make sure you submit 1 and 2. You'll get full opportunity for full credit, I should say. The later it is, the more late deduction points you're going to get off of it if not turned in today. So if you're extremely bored, I guess you can finish up those assignments while you're listening to me if you want to multitask. But anyway, that's not very optimistic. So let's go on to something that's more optimistic, SQL. So let's see. It says Introduction to SQL. And let me start it out here. This is lecture number 5. I'm going to kind of flip through the reason why we're doing this, just to give you the background on it. This is the way you talk to databases. In fact, this is the way you talk to all databases. Every database uses a dialect of SQL. There is really only one version of it. There's extensions to it, like Oracle has PLSQL, and they have their own version of SQL. But it's on the base scripting language of SQL, which means it's supposed to be following the same standard. It's a very, very high-level language. It's not like programming in C or Java. It is not really programming. You're writing statements. So it's not even scripting, if you think about it. It's querying. You're going to query a database for data that you want to get out of it. And it specifies a lot of data manipulation details. Oops. Yeah, don't want to move on yet, but I'm getting there. What makes SQL viable is that its queries are optimized as well. So the database itself, like MySQL, which is what we're going to use in this class, or Oracle, has their own way of optimizing the query. So you're writing a statement in English, perhaps, well, very similar. Well, it is English, but it's very similar in English speak. And it runs on the database, but the database engine translates the expression, turns it into source code, or turns it into programming, essentially, and then runs it. So it runs pretty quickly, actually. So we have we have basic syntax here, and let me just show you the convention on the slide, because as you're going through it, a lot of students, if you've never seen this before, start out going, does it have to be capitalized and does it have to be in blue? No. So the keywords in the slide set are all capitalized. For example, select from where are all capitalized. Only for the lecture. In the real world, they can be lowercase. And I put them, and I tried to put in most cases the keywords in blue. So the principal form of a query, and this is for data selection, is with these keywords as an example, select. So you could say select first name, select last name, select star. And then you're going from, and the from is one or more tables. From table 1, comma, table 2, comma, table 3, comma, table 4. And then the where is actually optional. Where is going to tell you where first name is equal to Barb, or last name is equal to Hecker, or something. Or where, I don't know, something is equal to something, or not equal to something, or greater than something. Those are the conditions you're going to put on the rows on the tables that you're going to extract from this query. I wrote this on 3 different lines because it's kind of interesting. It keeps me or helps me kind of figure out, especially for a long query, where everything is at. I can fill it in when I want to fill it in. For example, if I wrote select from where on a piece of paper, I could fill in the table names on the from, and then I could go back and fill in the select, and then I can get rid of the where if there was no condition. Makes it easier to write. I find that sometimes beginners, it's easier for them to put it on 3 different lines. However, you'll see a lot of people in the industry put it on one line. Just put it on one line. One query on one line. And when you write a query that you're going to use with a database for a web application, let's say in PHP or something, you have what's called a query statement. This is what we're learning today, the statements. And mostly the statements is a text string. So it doesn't really matter if there's line returns or anything in it. It just comes through as one text string, essentially. So imagine opening and closing quotes, and all of the space, well, the spaces are not ignored, but all the line returns are. So for our venture into SQL today, we're going to look at, and this is what I was trying to tell you before, it's kind of entertaining. What I want to do is actually go backwards and build, because last time we created an entity relationship diagram, several of them, and we translated them into tables, and you did this for your assignment. And I want to tell you why you were doing this actually at this point, because it creates a third normal form database and structure. But there's another reason. If you have the tables spaced out correctly, you can actually, and in fact I can sort of visually see, I've got 1 entity, 2 entity, 3 entity, and I've got 1 relationship, 2 relationship, 3 relationships going on here. Because I can visually see the way that the attributes are underlined. I can see that this is a primary key, this is a primary key, and this is a primary key. And the cheat sheet on this is that, there's only 1 key underlined. It doesn't contain anything else. If it's just 1 key, and every table has to have 1 primary key, or should have 1 primary key. And just to refresh your memory, because I'm reviewing a little bit from the last time I saw you, was that if you don't put a primary key in there, no problem. Only thing is, though, is that the table will be indexed on the primary key. So the table will run much faster. And then if we query on the primary key, the query runs actually faster. So if you want to optimize the speed of your database, put a primary key, 1 primary key in at least every table, and query on it. So when we go through, you'll see that we're actually querying on these primary keys. We're querying on the data. But I want to go backwards a little bit because I want to refresh your memory on those entity relationship diagrams. And I'm going to build real quick the ERD using ERD plus, what that actually looks like to show you that that's what we're querying. It takes about 10 minutes, isn't it? It's worth the exercise because then you can sort of refresh your memory on that, especially if you're still struggling with that first or second assignment. So all the queries that we're going to run are going to be based on this relational scheme, and this is the database schema. And the underlines are indicating the key values or key attributes. So I'm going to put this way for a second. And I have already brought up, well, I thought I did. It's probably in Firefox, actually. Oh, yes, there it is. And don't use Chrome, as I was mentioning before. Don't use Chrome for this. You can't save files, or excuse me, Safari. Don't use Safari. Chrome would probably work. Firefox actually I find works better for ERD plus the website. I don't know. It might be just my preference though. So Chrome, Google Chrome I know works. Yeah, it does work. It's a Safari that has issues. Yeah, I meant to say don't use Safari, and I kept saying Chrome because I was going to say do use Chrome, don't use Safari. So anyway. Make this a little bit bigger, move it over here. So what I'm going to do is I'm going to go backwards, and there's my 1, 2, 3, 4, 5, 6 tables. I'm going to work this backwards so you can see where the design is in here. And the reason why I'm working it backwards is because one of these days, hopefully in the future, you'll be designing your own database and you'll put together ERD maybe. People don't like to do that stuff. They just like guess at it. If you follow the methodology correctly, if you put together an ERD and translate it into tables, you should be able to take the tables and translate it out into an ERD. If you can't take the tables and translate it out into an ERD, you got a bad set of tables. And you're not in third normal form, and your database pretty much just, there's no other word other than sucks, or, it just is not going to, you're not going to be able to query it properly. and it's not going to run properly, and your queries are not going to work. So if you have access to the database tables, you can easily tell if your structure is good or not. Otherwise, what ends up happening is when you run your query, and let's say, for example, you have two tables that are holding the same data, which one do you query? Or you have this scenario where the data is not linkable. Like there's no foreign key in this table to match the primary key. So there's absolutely nothing you can join the tables on, I mean, realistically. Or you notice that, wow, I'm not keeping track of people's names. And data is missing from what you need to do. All right, so without further ado, let me hack away at this one. So I'm going to go real quick because we already know how to do this. And I'm going to create an entity relationship diagram. This is a review from last time. So I'm going to pick out my entities first because I know that these exist. And this one's called beers. And I'm just going to stick them here. And then I'm going to move them around. Bars. And drinkers. And I know I have 3 relationships because I see I have 1, 2, 1, 2, 1, 2. You can probably tell where they're having relationships with because of the 2. So I have a primary and a foreign. So if that's the case, I can go to drinkers, and they probably frequent bars. So we have a drinkers and bars relationship here. Oop, that's beers. Let's take beers out of the way. Put drinkers up here. Generally speaking, and this is kind of funny because I came in with my Bevmo lunch bag today, which is kind of ironic when I think about it, because generally at the end of this lecture, most people want to go out for a beer. Even if you don't drink beer, you're going to be like, I'm subliminally wanting a beer, and I want to frequent a bar that sells the beers that I like. Because that's what we're going to be working with. Well, at least up until lunch. So, but don't go for a beer at lunch. That's such a good idea. Unless you take me with you. Then you can go for a beer at lunch. All right. So this is the frequents relationship. So, and this is the frequents table, and we have drinker and bar. Well, we have drinker. So I'm going to fill in some attributes then. And if I do that, I'm going to say that we have a drink. I'm just going to do drinker first. We have name, address, and phone number, and name is a primary key. So I'm going to go name. I'm going to actually go drinker name. Drinker name. Address. And phone number. Hello. Phone number. And I have my side panel hidden, but I could say the drinker name has to be unique. There we go. And then I can put in the relationships by doing the connect. Oops. Fortunately, with the tool, you keep having to press the connect over again. There we go. And then I can actually connect again the drinkers with the frequents. And I can connect as well. While I'm here, I might as well just do it. There we go. So if you're having problems getting your connect working, because today's the day everyone's going, I can't get it to work. I can't get it to. That's one of the problems. You have to keep clicking on this if you're using this tool. All right, so now we have a very similar looking table as we do in the diagram here. And this is for drinkers, by the way. So I'm going to fill in bars next. And just the same way I did it before. And this will go faster here. Name, address, and license. So bars has got name, address, and license. And if you are watching this video and you didn't watch the first weekend and you're interested in finding out what tool this is, it's called ERD+. You can just pause the video and look at or take a look at the subject line if you're not familiar. And I'm going to go ahead and connect. It's much easier to do this because I can move things around, although it is a bit tedious. All right, and so in here for bars name, so name is here. I'm gonna actually change this name. I'm gonna call it bar name, bar underscore name, and I'm gonna make this one unique. There we go. When I make it unique, it's not really making it a primary key, but in the diagram it's doing the same thing. It's underlining it for me. So unique and primary key are very similar, except for primary keys. If you're actually making it in the database, the table will be indexed on it. It's not indexed on unique keys, but so don't follow that terminology correctly. All right, so let's see, bars. Oh, we got beers in here too. So drinkers, frequent. So we got frequents out of the way. Now we have likes and sells. Well, bars sell beer. So I'm going to put that other relationship in here. I'm going to call this one sells. And the sells table has a price, and then it has a bar, and then it has a beer. So bars sell beers. And so I'm going to add my connections here. Because bars sell beers. And let's move this way. Move this one this way. And I'm going to add the attribute for the price in here because that's a no-brainer. There we go. And because they sell many, and this is a many-to-many relationship, and I'll fix the keys in a few minutes. This one's going to get the relationship's going to get one from here and one from here. Well, from here it's going to get bar name on the cells, which is bar here. This is bar name. I renamed it to make it a little clearer. And then we have beer, and then we have price. Well, that's the beer, and then we have the price. So the beer, let me fill in the beers. Name and manufacturer is what we get on beers. So name. I'll put them down here. Manufacturer. Oops. Manufacturer. And I'll connect these guys. And because this is an entity relationship diagram and I'm going backwards, I don't have to fill in the other. I don't have to take it to this level. But we do know, because it's a many-to-many, that this turns into an entity. Well, it turns into a table. And then we draw one from here and one from here. And in this case, it's the name. This is going to be a beer name. Oops. I'll just move this way here. Beer name. And that one's going to be unique. And then manufacturer. And then this one is going to get the 2 foreign keys when we translate it. So I believe I have likes left. And we have drinkers that like beer, looks like. So likes relationship, one more relationship to add. Likes. And I'm going to stick it right here. And then I'm going to say connect the likes to the drinkers. I guess I'll do it this way so it looks better. And then I'll connect the drinkers to the beers. That looks a little better. Move it up this way if we wanted to. You can get carried away with the placement of everything. And in the likes, we know drinker and beer. So drinker and beer, because many drinkers like many different beers. And likes doesn't really have any attributes of its own, not like the price for sells. So if I put this side by side, see if I can get this side by side. And I'll leave this up just so, I'll leave it in the background just so we can refer to it later. We have 1, 2, 3, 4, 5, 6. We have 1, 2, 3, 4, 5, 6. 6 items. These are many to all of them are many to manys. So they all turned into tables. And we added a price to the cells. We don't necessarily need to know. We could add probably season or something. I don't know. Something to the likes table maybe. But this is what we did last weekend. So it's just put into another example, just in case you needed one. If we started with that, we gave this to the developer and they gave us this, now we know we can query it. And if we get this from a developer, here's your tables. Like, is this all the tables? You know, how are you going to tell? Well, if you start putting it together like this, you'll be like, well, where's the drinker table? Where's that table? Because the funny thing is you don't always get all the information you want or need. Instead, they say, you know, here, write the interface to this. Here's the query. Here, they're not going to tell you the queries to run. Instead, they're going to tell you, here's our database. These are all the tables. And here's the front end. It's a website. You're going to need to take all the information for the customer and update them in the customer tables and stuff. Well, first thing you want to know is you want to make sure you got it. And here now I know I have all the tables, first of all. Second of all, I know it's in third normal form. Third of all, I know all the data is logically located where it's supposed to be. So now I can query this, no problem. So third normal form tables make for really interesting and good queries that work. So anyway, I just want to go through that exercise as a review from, this is what we did last weekend. So now that we know this theory, and what I'm going to do is actually save this, because save diagram file. There we go. Because I'm going to put it away and go back to the lecture. Unless we have any questions or anything. Oh, okay, good. So we're going to move on then. So going back to here, because I know I lost you from a few minutes ago, perhaps. Select from where is our basic query concept, as I just covered. These are the tables we're going to use. So the first query we're going to see is an example of how to run a basic query. So using beers that has name, manufacturer, what beers are made by Anheuser-Busch? Okay, so select name, and then you see that these are in caps for illustrative purposes. Once again, I didn't make them in blue, but they're in caps. They can be in lowercase. Actually, you can capitalize the S and select if you want. You don't have to. Most people would put the keywords in caps just so that they know they're keywords. And you can write this all in one line again, as I was mentioning before. So select name from beers where manufacturer is equal to Anheuser-Busch. And one thing important to note is the single quotes around Anheuser-Busch. When we write queries later in MySQL, we'll figure out that the double quotes work too. Some databases will take singles, some of them will take doubles. In either case, it's a quote. Everything inside of the quote is case sensitive, however. Nothing else is case sensitive, just what's inside of the quotes. So we have the select name. The name is in the, we just looked at that and we just created the, and one of the reasons why I wanted to do that is now it's fresh in your mind that the beers table has a name and manufacturer in it. So name actually, believe it or not, is the primary key. So we're searching and we're selecting on the primary key. This is going to yield a very fast query results. If we didn't, we made manufacturer maybe the primary key, which probably wouldn't have been appropriate because manufacturers make multiple beers. And then we would be working with a different scenario. So what are we going to get back? We're going to get back a result set that looks like this. It's going to say name, and we have Bud, Bud Light, Michelob. And I apologize if you don't like beer, especially these domestic beers. For some of you who came in late, I was saying earlier, at the end of this lecture, you're going to want to have a beer, even if you don't drink beer. So it's just the nature of this lecture, anyway. So the answer to this relation is a single attribute, name and row, and the name of each beer by Anheuser-Busch, such as Bud, Bud Light, Michelob. Michelob Ultra is not bad, by the way. So I've tried that. So the meaning of the single relation query, well, this is what actually happens when the query gets run. You begin with the from, which is the tables that are on the from clause. You apply the selection indicated by the where clause. And then you apply the extended projection indicated by the select clause. So if I were rewriting this language, I would put the from first, the where second, and the select third. That's why I like to write it on 3 different lines, because when I'm doing it, I'm going to go, okay, what table am I looking at? Aren't you originally thinking about which table you want to query from? So then I would come back, and if I wrote select from where on a blank piece of paper, you know, actually, I can do that. Actually, I can mimic. Hold on a second. Let me pull out some scratch paper here. Here's my scratch paper. If I were writing the query, I would do this. I'd go like select from where. And then I'd say, okay, select from drinkers. Drinker, maybe. That's one of my tables, I know. Or actually, this one says beers. Beer. And if the table has a capital B in it when you put it into SQL, then you have to use capital B. So a lot of people will put in the query, let's say you created the table and the table is all in lowercase. They'll use a standard so they know whenever it's not mixed matched. In all cases, all the table names are all lowercase, maybe, because you put them in that way. That way you know when you write the query, if you put it in lowercase, you're going to use it here in lowercase. And then they'll put the keywords here in uppercase because it's easier to see that that's a keyword. So let's see, where. So what am I going to select? I'm going to select name from beer where name doesn't equal Bud Light. And then I didn't mention before, and that's a, well, let's see, let's go equals right now. That's a not equal. This isn't equal. I'll go through those in a few minutes. And then I use, because I like double quotes, and that will work in MySQL. I use the double quotes. You can also put single quotes in here. And then all of your queries end with a semicolon. You don't have to do it like this, is what I'm trying to say. You can do it like this. That's the same query. Okay, that might look a little bit more sophisticated. Or better yet, you could do this. You can go select name from beer where name is equal to Bud Light. That's the same query too. Not case sensitive, except for whatever's in quotes. That's worth spending a little time on, because then later on you're going to go, wait a minute, why is that different? Oh, because. So it starts on the from, goes to the where, then uses the select. And so there's an algorithm in the back. It's called a row variable. And it searches. It does a search algorithm that ranges over the rows in the relation in the from. And it checks if the current row satisfies the where clause. Is this equal to that? Is this equal to that? It's almost like doing a linear search, but it's not implemented like a linear search. So if you know data structures, algorithms, in the data structure here, it's a table. And it's going to do a index on the table through the primary key. It's going to use, if you're selecting the primary key, it's going to use the index first. And then it's going to go to the indexed primary key, and then it's going to find the associated data. Fortunately for you, you don't have to know any of that. And you don't have to use that. You can just blindly run a query and never know exactly what it's doing. If you're writing your own database language, then it's kind of interesting to see how that works, in essence. Then we have this little asterisk, and the asterisk is cool. It means wildcard. If we don't want to select just the name, we want to select everything, then we go select asterisk, and it stands for all attributes in this relation. So using beers, same query we did before, but instead of selecting the name, we're going to select star. From beers, where the manufacturer is equal to Anheuser-Busch. This will give us this, oh, not like that, but something similar to that. There's a word wrapped on me. So, Bud Light with manufacturer. So, forget the rest of this because it's all scrambled on my screen. Name and manufacturer instead of just name. So, in here, we just wanted name, we got name. So, here we got name and manufacturer. We can also rename the attributes. So if you want the result to have a different attribute name, you can use the as, the new name, to rename the attribute. Here's an example. Based on bars, manufacturer, and name, select the name, because what's a name? I mean, I actually said beer underscore name in my table, because I'm like, well, I don't know what the name really is. Well, you can say name as beer, and then manufacturer, so it says name as beer. This is the renaming. It's kind of like a rename. And then manufacturer, comma manufacturer. So manufacturer is going to show up as M-A-N-F, and then name is going to actually show up as B-E-E-R, beer. And then from beers, where manufacturer is equal to Anheuser-Busch. It's the same query as we did a few minutes ago. But now in the query results, it's still messed up as well. Same query. So we see that now instead of saying name up here, it says beer. So it's a way of renaming the columns. And most people are like, well, why in the world do you want to rename the columns? Well, you rename the columns when you're running a query. You're going to take this query result set back to a website maybe, and you're going to populate the data on the screen using the website. Excuse me, using the query results, and you don't know what name is. or you don't know what something else is, and you want to be able to get the metadata out of the query result and go, okay, name, or wait, beer is Bud Light, or the program that's parsing the query results is looking for a key attribute that's not there. So you're going to put the attribute in by renaming an existing attribute. Yes, you had a question? Yeah. I'm sorry. Select name as beer. In the query result in the previous, name is the name of the attribute. So name shows up in our query result. If I say as beer, I get beer instead of the word name. It renames the attribute in the result set. So it gives it a new name. It's like an alias, but it's not really an alias. It's just a rename. We're going to see another example in a few minutes as well. Here's one that might make better sense to you. Yeah? Yeah. Yes. That's a very good question, actually. She was saying that in the diagram that I wrote, I changed name. I wrote, actually, let me see. I can tell you what I wrote. It's in the beers table. And in the beers table, where's beers? Here's beers. I wrote beer underscore name. That's the one I have to query on. I changed it because I didn't like name. Well, that's why we're changing it in the lecture, actually, too, because what's name mean? Beer name. How is that name different from, and then in the drinker it says name. Drinker name, beer name, name. Everything's called name. So unfortunately, I want to change it so it's more meaningful. I use the as. Makes it renames it in the result set. But yeah, you have to use the name that's in the actual table, and it's case sensitive as well. So if it started out with a capital N, I'd have to put capital N here too. Otherwise, it's not going to know what it is. That's why people will put everything in lowercase. Yeah. There's no way of linking the diagram with the query sentence. The diagram is going to tell you, or the set of tables, but usually the diagram is going to tell you if the query will work. And the diagram, going backwards here, the diagram actually, oops, not this one. What did I do with it? I know I didn't leave it. There it is. If I want to figure out the bars that sell beer, I know the table names. So I can say, select, well, this is really the sales table. So the from line would have sales on it, and then I would probably select the bar name, and then I would probably say the beer name from sales. And then I would get all of the bars that sell beer, what beers are sold at the bars, or which drinkers frequent bars. So the diagram helps you visualize, and this is a very small example with only 7 or 5, 1, 2, 3, 4, 5, 6 tables. What if you had one with 100 tables and you don't know which ones are related to which ones? Like somebody gave you, this is really sadistic, but some really weird person kind of gave you like this, and it had 10,000 tables in it. Actually, not that many, maybe 1,000, 50. I should just multiply it by 10. Make it 100. I mean, make it a big amount. It's really hard to see what in the world, what in the world goes with what. So most people would find themselves, and this is what I used to do actually. I used to take them in little groupings and say, all right, these look like relationships. Let's pull these guys out over here. These guys, they look like tables for entities. Let's put them over here. And then I found myself going, well, let's just put them together in an entity relationship diagram. Because then I know, for example, I'm over here looking at this. All this stuff's out of my way. If I'm looking for something about the beers, I'm looking for a piece of data about the beers. Like I want to know the beer manufacturers because I want to sell them a flyer to advertise my new bar or something. And I need to run a query to find all the manufacturers for all the beers that are out there. I can eliminate everything except for this one little table. All I gotta do is look for manufacturer. Now, if I did that in a query, using a set of tables instead of the diagram, I get the same result. So either way works, but it's kind of like a picture says 1,000 words. You know, to look at a picture of something makes it clear than reading 100 pages of text about something. So your preference. There's a lot of people out there that don't like entity relationship diagrams. They would prefer just to look at the table list. More power to them. I get lost with the tables. I end up missing a table, or I end up not seeing all the tables, or not even knowing which ones are relating to which ones. So if the tables are designed correctly and they actually came from an entity relationship diagram, sometimes they'll actually give you the ERD. So if the developer used the ERD, they'll give you the ERD instead of all the tables, which is even better because you don't need all the crap in all those tables. All you need to know is what you're looking for. Once you find the base tables you're looking for, then you can go searching on the criteria that you're interested in finding. So, all right, let's go back to another example of the as. We have an expression here that makes sense that appears in the select clause, for example. Select bar, comma, beer, comma, price. This is all on one line, it's just word wrapped. And the price times 120 as price in yen. I don't think that's the current price of yen, but well. Price times 120. And it's from the sales table. There's no where. So we left a where out. It's just an illustration telling you don't need to where. It's optional. But the as price in yen is going to give us our results that look like bars, beers, and price in yen. And looks like we got a little space here. A little extra tab in my results. But bar, beer, and price in yen. We got Joe's bar, Sue's bar, maybe. And they have Bud for 300 and Miller for 360. This is good because then we can write another query that says like price in pesos or price in euros or something. And we know that the calculation is for different currencies, and we know which currency it was because we use the as in our result set. So the as is going to tell us price in yen, when really it's just the price times 120. Good. Good. We'll take a break in another 15 or so minutes. It's good. This does get a little tedious after a while. Here's another example. And so from likes, drinker and beer is in likes. We're going to select the drinker, comma, likes Bud as who likes Bud. So it's this is what's called a constant expression. In the results set, we're going to put this constant expression in here to keep track of who likes Bud. It's from the likes, and then here's what I was doing before. I was saying where beer is equal to Bud or something. But the trick here is right here. Select drinker, comma, likes Bud. Well, that's a constant expression. It's really a fake column. As, and now we're working this with the as again, who likes Bud. So the result set kind of looks like this. Drinker, who likes Bud, likes Bud, likes Bud, likes Bud. Every single one of the rows that comes out is going to have a likes Bud next to it. And you're like, well, why are we going to do that? Because if we run the query a couple more times, just like the price in yen and the price in euro, we're not going to know like what that is. So this helps our result set explain to us that these are the people from the query that we ran where the beer is equal to Bud. So if we had another one that said beer is equal to Corona, then we would say as who likes Corona. And so our result set would say likes Corona, maybe. We're doing this because now later on we can tell what the results were. Otherwise we don't know who these people are, what they like. Because normally without that expression this would be missing. We would only get this. If you select drinker, that's all you're going to get from sales. You're going to get drinker column. You're not going to get this one unless you put the alias in here. It's not really an alias, I should say. It's a constant expression. Now we have conditions in the where clause. So let's see. Select price from sales where bar is equal to Joe's bar and the beer is equal to Bud. All right, so now the bar is equal to Joe's bar. Well, we got an interesting thing here. We have the two apostrophes because there's an apostrophe in Joe's bar. We balance it out. So we cancel out we put in a single apostrophe by using a double. So it makes it so that we can use apostrophes inside the quotes. There's a little trick actually in MySQL. You can use double quotes with a single apostrophe on the inside, but you still have to go double apostrophe on the inside, which is weird. It takes the singles and the doubles as the same symbol because people like double quotes versus single quotes. Go figure. You still got to cancel it out though. Anyway, and here we have the beer is equal to bud. We're going to use an and this is the different part. We're stringing them together with an and. So this is where the bar is equal to Joe's bar and the beer is equal to bud. So I actually just talked through this. The only point that's not mentioned so far, I mentioned it earlier, was the case sensitivity. So SQL is case sensitive, so anything you put in here, you actually have to capitalize the J in Joe's bar and the B in bar. Otherwise, it's not going to match because the bar is going to be equal to. Wait a minute, that's not in there. It has to be an exact match inside the quotes. We have like, and then we have not like. So for patterns. So where clauses can be, the where clause can be conditioned so that we have like, this attribute is like this pattern. That attribute is like that pattern. Well, what's the pattern? We have the wildcard, the percent sign for any string. Then we had the underscores for any character. Well, let's see what that looks like. From drinkers, that has a name, address, phone number, find the drinkers with exchange 555. So select name from drinkers, where the phone, and this is the like. So if it's like, it can't be equal to. You remember what I said before about the equals? It has to match identically. Unless you have that in the database, it's not going to match. So you use like or not like for equals or not equals. So if it's like, this says anything. So you could have like 1, 408, 555, or something. Any number of characters or strings leading up to 555, and then a dash, and then 1, 2, 3, 4 characters of any sort, but only 4 characters. Okay. We're going to play around with this later, so you'll have the, it's hard to do it from a PowerPoint, but I have to show you the syntax first so you know what you're writing. So anyway, this is lecture 5, by the way, as well, because you'll use it to look up some of the syntax later. Actually, believe it or not, that's the basic query. We've actually gone through most of it already. We're going to put queries with queries, and we're going to look at some of the different oddities about it. But if you can get the select from where down, you're in pretty good shape. Actually, it's not asking too much. Null values. Well, a null value doesn't have a value. It's empty. They call them null instead of nil. It's N-U-L-L. In the rows in SQL that do not have values, you can have one or more or as many as you want. That's why there's always these things that say not null, which means the value cannot be null. So it's a flag you can put on when you create the table. We'll be creating some tables later and you'll see what I'm talking about. Missing values, we know that Joe's bar has some address, but we don't know what it is. Then it's null. It's inapplicable, for example. A value that has an attribute spouse for an unmarried person, you're not going to have it. Second address is sometimes null. You have address line number 1, address line number 2, but you don't live, like, your address is kind of short. When you're comparing nulls, we have three Boolean logic kind of thing. Boolean logic is true or false. When you consider the null, now we have 3-way. True, false, and unknown. It's unknown because it's in between. It's a half. It's not a 1, it's not a 0, it's a 1/2. Because we don't know if it's one way or the other. It's in the middle of true and false. It's unknown. So if you know that, you'll know that then if you ever do a query on an attribute and there's some nulls, the nulls aren't counted. So nulls can't be true and they can't be false. So you're like, well, what are they then? They're nothing. They're empty. So if you do a count on a column that has nulls in it, the count will be wrong because it won't count the columns with the nulls, which kind of throws off your query results. Okay, here's what happened, and this is interesting. You go and you run a query and you want to count how many customers did we sell products to today? And then you realize that you're counting the customer's last name. And then there's one that has a last name unknown or something. And it says null in there or something. Well, that person doesn't count in the count because the person doesn't have a last name and you're counting all the last names. Then you're off by one. You're one short, if that's the case. So then generally what ends up happening is people are writing the applications and running the queries. They go back to the database person. Hey, your database is wrong. And they go, well, what are you querying on? And you're querying on a column that can be null. Okay, well, that's a problem. So you don't want to ever query on a column for count on a column that can be null, because your count will always be wrong. Unless you wanted to know how many people bought something today that have given us their last name. That's a good one. Or better yet, what will end up happening is you'll have the same customer in there twice with 2 purchases, and there's 2 entries with 2 different two same last names, and they only get counted as once if you're counting unique instead of twice. Anyway, counts are notorious, and I'll go through some examples of this shortly. Counts are notorious for throwing off logic. Or nulls are notorious for throwing off logic for counts. Put it that way. So here's an example. From the cells relation, we're going to select the bars from cells where the price is smaller than $2 or the price is larger than or equal to $2. Well, we don't have in the sales table, we don't know the price that Joe's bar sells Bud for. It's null. So it comes back and the entire query will come back unknown. Don't know. Well, that's because we don't know the price. So bottom line, in the back of your head, if you're ever having a problem with the query results and they're not equal to exactly what you think they're supposed to be equal to, you're doing a count or you're trying to do a calculation on something, check to make sure that you have not null as an attribute characteristic. So I'll go through that when we start building tables, how to make something not null. Then you don't have to worry about that problem. Because if it's not null, you have to put a value in. So then people put in values like 123 Sesame Street or something, or unknown. Actually, there's in the database for most of international students, sometimes the first name, last name, surname, it gets messed up in the system. And so it'll say, first name unknown, last name unknown. And then it actually shows up on my roster saying that the last name is unknown. I'll be like, really? Is there a last name unknown in the room? You know, so it's because they have to put something in there because it can't be null. So anyway, that's databases make the business rules. Unfortunately, the business rules are supposed to be making the database rules. So that's why people have these really weird defaults. Oh yeah, just put in 5551212 if we don't want to do your telephone number. Most anyone who's ever filled out a web form who has not wanted to give out your information, you wanted to leave a blank, but it forced you to put something in there, you know the tricks. Everything's at Gmail. So it's, I'm not giving my email address at gmail.com or it's 5551212, which is, you know, information. Or better yet, I like the 408, 408, 408, 408. Just put numbers in there. Or 1111. And then we have the fancy form checkers that look for that stuff. So they're making it more difficult these days. So, anyway, I never give out my telephone number. Instead, I used to give out an other number. In fact, the people that own the number that I used to have, my old number, are probably cursing me. For the longest time, I used to give out the telephone number for Wells Fargo, actually. So if you can remember like a bank number or something, you can, you know, when it says telephone number, you just put somebody else's number in there. They're never going to call you. Or somebody else's email, like info@yahoo.com. Yeah. Anyway, a little side tangent, but I don't know, it's kind of interesting. You can actually query multiple relations now. So you can address it in the from clause, and you separate them out by commas. And you use a relation.attribute syntax to figure out how you're going to get at each one of the names and attributes. So using the relations likes, and likes has drinker and beer, and frequents that has drinker and bar, and we have 2 drinkers now, 2 different tables that we want to query. We want to find the beers liked by at least one person who frequents Joe's bar. I think there is a Joe's bar, actually. It's not in Palo Alto, I think it's in San Jose. Just in case, you know, subliminally in the back of your mind later on, you're going, I need to find Joe's bar because I need to have a bud. You know, anyway. Select beer. This is what we're looking at. This is what we want. So we're selecting what we want out of there. It was just beer. From likes, comma, frequents. So this is table number 1, and this is table number 2. So likes is the first table, frequents is the second table. Where the bar is equal to Joe's bar. And here's the new part. Frequents.drinker is equal to likes.drinker. The dot and the table name is what's differentiating the drinker equals the drinker. If we did drinker equals drinker, we're not going to be able to tell which table the drinker is coming from, because the drinker is in both tables. That's why a lot of people, well, even so, I would probably say that's the drinker name, really, but the way that you label something, if you have 100 tables and you're actually doing entity relationship diagramming correctly, and you actually have the relationships with the real foreign keys from the primary keys, and everything's done correctly, you have to use the dot notation when you're using the tables together. So this is using it's using likes and frequents, which are 2 relationship tables. So we have to, and because the relationship tables are going to have the same attribute in them from drinker. So bottom line, use the dot notation. And the tables here were capitalized. So that's why the capital L in likes and capital F in frequents. We're good with this. Very similar to object orientation, but some of you guys aren't computer science background. So you may not be familiar with object orientation. Formal semantics, almost the same as the single relation queries. You start with the product of the relations from the from clause. So you take, starts with from, goes to where, and gives you the select. Just in case you're curious about what happens in the background. You apply the select condition from the where clause, and you project onto the select clause. Get the items. So put these 2 tables together, find out where this exists, and then bring back the attribute that you would like to return. That's what I just said, actually. So. Okay, so that's basically in a nutshell what I just described. So I'm going to skip those slides because I've been meaning to take them out of here and I haven't done it yet. It just confuses people. It's the same thing we saw with the single relation. You just put a comma and you have 2 relations and you use the dot. So here's another example that will put it all together as well. From beers that has name and manufacturer, find all the pairs of beers by the same manufacturer. So do not produce pairs like Bud, comma, Bud. And produce pairs in alphabetical order. Bud, comma, Miller, not Miller, kind of Bud. And you're like, this seems like a huge step up or something, but it isn't really. The difference here is you have the same table twice. So you select, and you're like, well, if the processing really starts with the from, this is already known. So if I have select from where, same as before, on the from clause, if I start there first, I have beers B1, comma, beers B2. And then on the select, I'm going to go B1.name, B2.name. Because otherwise I got name, name. Or I got beer, beer. Which beer do I want? I'm querying the table with the table. Trying to find the matches within the tables. And the matches are going to be finding all the pairs of beers by the same manufacturer. And that's where the where clause is coming into. So B1.manufacturer is equal to B2.manufacturer. So you take in the one table and you're querying it on another table, but the other table is the same table. Querying the table twice onto itself. That's what you're doing with this. And the way you're getting the alphabetical order is this part here. So if you took this part out, you wouldn't get the duplicates. You'd get duplicates and it would not be in alphabetical order. So B1 manufacturer is equal to B2 manufacturer. And B1.name is smaller than B2.name. That's how we're getting the alphabetical order. If you did a comparison like 1 smaller than 5, it would come back true because 1 is smaller than 5. If you do it with text strings, which is what this is name, if the name, it starts with the first character. So if the name of the beer, one was the one on the left, I'm going to make a true one here. We're looking at apples and oranges. Or apples and applesauce. Ooh, actually, that's a hard one. Apples and what's another? Apricots. Apples. No, that's a PP. You start with the first character, and if A is smaller than in the scale is smaller than P for pear or for orange, that's an easy one. It is smaller. Then it comes back true. And then if the first characters match A to A, then you go to the second character, then you go to the third character, then you go to the fourth character. Eventually, it's alphabetical order. Eventually, you're going to get it in alphabetical order. If it's true. Otherwise, it's not going to come out on the screen. You're only going to get the alphabetical orders. If that's a little bit complicated for, I don't know, the morning of Saturday, so. And then the SQL, it has to marinate a little bit, which is why we're going to spend all day on this. And in the afternoon, when we start writing the queries, you're going to go, oh, let's go back to that PowerPoint, because I know the syntax is in there. And then once you start using the syntax and start thinking about it, we'll go through a couple of exercises this afternoon where we'll build some tables and we'll run some queries. And most of the pieces will come together. But I have to show you the syntax first so you know what to apply. So, subqueries. I'm going to do subqueries, then we'll take a short break because some people have been here since the beginning. Subqueries. It's nothing more than everything we've looked at so far. Believe it or not, we've hit the entire language outside of subqueries and data definition, which is building tables and building queries, views and stuff. So let's take a look here. It's a parenthesized select from where used with another select from where. The basic concept again is the select from where. So an example here is in the place of the relation in the from, we can place another query. Now let's just take a look at it. If the subquery is guaranteed to produce one result, we can use an equals. If it's more than one result, then we need to use a bag or a set with that. I'm going to get to that in a few minutes, but let's just take a look at the one quick example, and I'll go through the slides I just kind of thumbed through in easier words, hopefully. If not, go back and read the slides. But from cells that has bar, beer, and price, find the bars that serve Miller for the same price Joe charges for Bud. So we want to go to Joe's bar. No, actually we want to go to cells table. We want to find the bar because we're interested in buying Miller. And we want to buy it for the same price that Joe's bar sells Bud for, because we're so used to going to Joe's bar and buying Bud, we like the price. It's only $2. So we want to find another bar that sells Miller at $2. That's what we're trying to do. We have two queries that we could run, and we can run them separately if we want, or we can put them together. So what we're doing now is making one subquery with another subquery, putting queries together. We actually, believe it or not, know everything about queries. Now we're just going to put them together. So find the price that Joe charges for Bud. That's step number one. We could do that as a separate query. Or we could find the bars that sell Miller at that price, which is after we find the price, then we can take the price and substitute it in two different steps, or we could put it together. And here's how we put it together. So we can select the bar from cells where the beer is equal to Miller and the price is equal to, well, what's the price? The one that's in blue on your screen there runs first. It's going to come down to one price. And it's going to be equal to the price from the, so the inner query gets run first and then the outer query gets run second. Well, the inner query says select price, right here, select price from cells where the bar is equal to Joe's bar and the beer is equal to Bud. We saw this query a few slides back. It's the same query, but it was on its own. This is going to produce the price at which Joe's bar sells Bud. So let's say it's $5. So this query is going to run first, and the number 5 is going to come out of it. And then this query is going to run second. So select bar from cells where the beer is equal to Miller and the price is equal to $5. So instead of running this query first, getting the 5 and rewriting another query as a second and substituting 5 in here, we're just putting them together. I think I'm gonna take a short break. I think people looking like they want a break. Let me stop the video. I'll actually stop the video.